Hi. So continuing to our session, let's move on to exercise 2, which is Ruby REST Client Backdoor. Now, still with Contra Application Security Training. Click Ruby REST Client Backdoor. Now we have about 14 steps to finish. So let's start by reading the background. It says that the following interactive tutorial details the code execution backdoor reported in the REST client gem for Ruby, based on the detail posted by Jussi called Jonen. The backdoor was introduced by an unknown threat actor in REST client. Okay, so for the reminder of this tutorial, we'll be referring to the threat actor as Bob. Okay, let's click next to start with the Ruby REST Client 1.6.13 backdoor vulnerability. So step number 2 here explains about pastebin. Yeah. Following a recent cyber attack against a well-known ISP, a group of hackers have published samples of compromised user data, including credentials, on pastebin. So the Bob here, as the professional cyber criminal, regularly monitor paste site like pastebin looking for the password. So let's have an access to the following link as Bob. Copy the link and paste it and press enter. And in step number 3, we saw that Bob eyeballs the password dump and identifies an email domain as well-known software company. Yeah, so you can see this is actually the email domain, and Bob runs a quick OSINT search by using Google and identifies the email address belonging to a well-known software developer named Andrew Manning. So this is actually the result of pastebin. You can find a lot of things on this particular pastebin website, which includes also the username and password of particular users. Let's move on to step number, as you can see here. Yeah, just to repeat, as you can see here that we got the username and password of an email called Poison Ivy. Yeah. The real name is Alicia Liao. Yeah. And the second one here, so we got the password and the email address and the first name of the customer. Yeah, first and last name of the customer. So move on to the next step. In step 4, the backdoor. Yeah. Further Google searches by Bob reveals that Andrew is an active contributor of a popular Ruby gem REST client. Now Bob will attempt to credential stuffing attack against Andrew rubygems.org. Yeah. So here Bob will need to access Andrew's RubyGem account and modify the source code file within REST client repository. Let's click Analyze Code to see the modification. So this is the original Ruby script. Yep. As you can see on the right side here, click Analyze the code. Yeah. So these are some changes made by the unauthorized user, right? So the explanation. Bob modifies the request. As you know, that Bob is the cyber criminal, modifies the request.rb file, adding a few malicious line of code. And yeah, as you can see here, we have he has added several things. Next, step number 5, Alice. It's time to introduce Alice, a developer working for a crypto brokerage firm called CoinPay. She manages a QA team and responsible for deploying the testing. Yep. And Alice, as Alice here, let's browse CoinPay project directory. Yeah. And when you're ready, we can just click next. Okay. So let's see. Where's my next button here? We need to copy this first, the command ls-la. And looking at the project directory structure, it appears that the CoinPay platform is developed using Ruby on Rails web framework. Let's click next. And now in step number 6, the gem file. Let's view the project gem file to understand the application's dependency on gem used by Alice for the project. Just copy the following command and put it into our console and press enter. Cat gem file, just to see the content of the gem file. Here, going through the gem file, we can see that Alice's project utilizes REST client gem, which offers an HTTP and REST client for Ruby. From the command, it appears that REST client library is being used in Alice's project to access data from third-party JSON RPC endpoint. And note that Alice builds the CoinPay project REST client gem with the will be downloaded from the rubygem.org gem source, which hosts Bob's Backdoor's REST client. And remember that previously Bob's was able to modify the content of the REST client code. Next, in step 7 here, we have this .env file. So let's have a look at the project environment, the .production.env by issuing the following command. Let's copy this and paste this cat.production.env. Okay, so you can see the contents and click next. Now the attack. Having previously modified REST client Ruby gem, Bob as the attacker registered the domain something, yeah, very long one here, and configure server pointing to his newly registered domain. So Bob then installed the Apache web server and configured the server to enable verbose logging, allowing him to view detailed log events for every HTTP request made by the domain that he has registered. Okay. And here we'll need to monitor the access as Bob. We need to monitor the access log by issuing the following command. Yeah, let's copy the command, tail, and show the access log. And then next. Now, here in step 9, Alice will load application. A few days pass and Alice deploys the latest build of her project on the following production server. So let's type or copy the URL, staging, and press enter. And step number 10, the exploit. Yeah, it's strange. After Alice successfully accessed the newly developed CoinPay project, a post log event is simultaneously logs on Bob's Apache web server. So let's have a look at Bob's Apache log file by analyzing the output. Okay, let's have a look at this one. So after Alice loaded the newly developed project in her browser's Bob log file, register a post request event. And as you can see here, we have a lot of information from here, the secret, the mail, host, and so on. So these are the content. So the body of the post request contains parameter, which is assigned with Alice staging server URL, which is staging jeff.media brokerage something.conpay.com, right? A second parameter here, the y, is passed. Notice that the content string looks quite familiar, or maybe not really that familiar, is vague, yeah. And then click next and see in closer inspection, it appears that the y parameter contains paste full set of application environment variable, including sensitive API, which is the application programming interface, keys, and database credential. Wow, this is dangerous, right? And step number 11, backdoor analysis. To further understand the backdoor, let's begin with analyzing the request.rb project that Bob's previously modified. Let's analyze the code here. So here, the code blocks start with the reals, something, something. Check to ensure that preceding code block is only run when project is running production mode. And then a new thread is then created via thread.new, and as you can see here that we have not a noticeable performance impact since the successive loop and eval begin invoke are the IO or input output type requests. And the code then initiates the loop, which will run every 15 minutes. And finally, after 15 minutes have passed, the code invoke a paste bin URL via open when contents are passed to the eval to be evaluated. As you can see here is the complete one. And finally, note that the innocuous empty exception handler is declared to silently ignore any errors that the backdoor may raise. Let's click next. After we have analyzed the backdoor, and if we want to further analyze the following paste bin URL, let's copy the paste bin and look at the content. And in step 13 here, paste bin paste contain Ruby code declaring 3 exception handlers. Yeah, let's analyze this by loading the code in our code editor. Okay, so this is still step number 14 about backdoor analysis. And let's analyze the code. First, the backdoor makes use of the Ruby Faraday gem, which is the HTTP client library that invokes the Faraday post method using for making post requests. Then the post here, the Faraday post method posts 2 parameters x and y. The first parameter x is assigned the URL host, which contains the server host name that backdoor is being executed on. The second parameter y is assigned to serialized copy of the application environment, which may contain sensitive API keys and credential, right? And then finally, the post is invoked to post this data to this particular domain, which is controlled by Bob. That's about the exercise. So, in summary, that the modified code by Bob as the cyber criminal allows Bob to take over the session and do a lot of malicious things. Okay, that's actually the main exploitation technique used by Bob based on modified code. Okay, so that's for our second exercise. See you in the next exercise soon.